In the previous video, I showed you how to do the kind of problem where you're going from z to p. You're starting with a range of z values and you're finding the probability or the percentage or the area. Now we're going to look at the other way around, the reverse of that, where you start with a p, a probability or a percentage or an area under the standard normal curve, and you find the z that goes with it, that marks the cutoff for that area. So in this video, I'm going to show you how to do that using Table E. And then a separate video will cover how to do that using technology, like a graphing calculator. So first let's talk about the simplest situation, which is where you're trying to find the z value when you know the area to the left of that z. So we'll just be doing kind of the reverse of what we were doing before. We're going from the 4-digit area, somewhere in the middle of Table E, to the z number on the outside that corresponds with that area. For example, let's say we want to know for what z value is the area to the left of that z equal to 0.378. If I told you that this red shaded region here has an area of 0.378, it takes up 37.8% of this whole thing, where is the z value that separates the red from the non-red? Where is this? From the way I've drawn it, you can tell that it's somewhere between -1 and 0, but where is it exactly? Well, here's how you would find that out. Turn to Table E, either in the back of your book or on that important formulas card. And remember how the table's laid out. It's in 2 pages. The first page has the negative z's, and those 4-digit numbers in the middle of that page range from 0.0003 at the top of the page down to 0.4 something at the bottom. So numbers between 0.0 and 0.4 something are on this page. And then on the other page where the z's are positive, we get those 5-digit numbers that are in the 0.5s and 0.6s and so on up to the 0.9s. So if we want to know what's the z value for the area to the left of that z to be 0.378. The 0.378 is an area. So it's one of those numbers in the middle of the table. And because it starts with a 3, it's going to be on this first page, where the numbers are from 0.0 something to 0.4 something. So if you look in that page, look in the middle of the page where those 4-digit areas are. The ones at the top start with 0.0. Then we got some that start with 0.1, 0.2, 0.3. And look for the closest thing you can find to 0.378. Okay, I see a 0.382, a 0.3783, a 0.3745. So I don't see 0.378 exactly, but I see 0.3783, which is pretty close. It's closer than any of these other numbers. So that is the one we want. I found as close as I could to 0.378 in this table where the areas are. Now, what is the z-score that goes with this? What is the z-score for this area? Well, looking over here, I see that the row that this is in is the row for where z starts with -0.3. And then it's in this second column, the one that has the 0.01 at the top. So that tells me the hundredths digit. So putting those together, the z is -0.31. So that is the answer. For an area of 0.378, the z value is -0.31. Let's try another one. For what z value is the area to the left of that z equal to 0.67? So 0.67 is the area of this purple shaded region. So I turn to table E. I'm looking for 0.67. Okay, here are my 0.6s, and oh, look right here, 0.6700. That does it exactly. And what z does that correspond to? Well, an area of 0.6700 goes with a z value of 0.4 and then a 4 after that. So the answer is that z is 0.44. Now, what about finding the z value when you know the area to the right of that z? Like if we know what this area is over here on the right, what's the z-score that marks the cutoff separating that from the rest of the area? Remember, the table gives us the area to the left. It relates z-scores with areas to the left. So before we can use that table, we need to know one of those two things. We either need to know what the z-score is, or we need to know what the area to the left is. So if we start out knowing the area to the right, first thing we have to do is subtract that area from 1. The whole thing is 1. So if we subtract off the part that's over here on the left, then what we have left is what's on the right. Or if we subtract off the part that's on the right, what we have left is what's on the left. So subtract the area to the right from 1 to get the area to the left of z. And then that is what you're going to be looking for on table E. You're going to try to find the 4-digit area that's closest to the result of that subtraction. And then once you find it, see what z it corresponds to. For example, for what z value is the area to the right of that z, over here on the right of the cutoff point, equal to 0.085. So if this red region here is 0.085 in area, where is the z? The way I've drawn it, it sure looks like it's somewhere between 1 and 2. It'd make it 1 point something, but what exactly? Since we're given the area to the right, the first thing we need to do is calculate 1 minus 0.085. That comes out to be 0.915. So the area over here on the left of that z, this part here, is 0.915. And that's what we need to look for on the table. So here I am on the table. I'm looking in the middle here, these 4-digit areas, and I'm trying to find the closest thing I can to 0.915. Well, there's a 0.9115, 0.9137, 0.9147, or sorry, 0.9131, 0.9147, 0.9162. I didn't find 0.915 exactly, but it would be somewhere between these two numbers. 0.915 would be somewhere between 0.9147 and 0.9162. So the z that I'm looking for starts with 1.3, and then after that, the next digit is, well, it's somewhere between 1.37 and 1.38. And it's actually closer to 1.37 because 0.9147 is closer to 0.9150 than 0.9162 is. So the closest thing to 0.915 exactly, 0.9150, would be 0.9147, and that goes with a z-score of 1.37. So that is the answer. Z is 1.37. Okay, let's try one more of these. For what z value is the area to the right of that z equal to 0.877? So first we subtract 1 minus 0.877 equals 0.123. So that would be the area to the left, and that's what we're going to be looking for on the table. Now I'm on the table. I'm looking for 0.123, somewhere in the middle where the areas are. I better be on the first page. So I'm looking for a number that starts with 0.1. There's a 0.11. Those are getting smaller. The next line starts with 0.13 and gets smaller. There's a 0.1292, 0.1271, 0.1251, 0.1230. Ah, there it is. That's exactly what I was looking for. 0.1230. Now, what's the z that goes with that? Well, if I follow that along over to the left here, that's in the row that has a negative 1.1. So my z starts with negative 1.1, and then the digit after that is a 6, because that's what column we're in. So the answer is z is negative 1.16.